Hey everybody, in this video I'm going to go through lesson 1.3, Introduction to Functions, and try to keep this short and sweet. So first, we need to talk about what is a function. And a function is a relation where each input, which is like an x value, has only one output, only one corresponding y value. So we are going to jump right into examples, and this first example is going to require the three graphs that go along with this lesson. So I have those right here. We are going to determine whether each relation graph represents a function. So I'm going to label these. This will be A, B, and C. So starting with A, if I want to determine whether a graph is a function or not, remember each x value can only have one y value. We are going to use something called the vertical line test. And what the vertical line test states is that if I have a straight up and down line, a vertical line, come on, I was hoping it would turn into a nice line for me. If I have a straight up and down line and I sweep that from left to right across my function, if at any place I cross more than once, so notice here, if I leave the line right here, this crosses our graph here, as well as down here. So this represents one x value that has two y values. So this is not a function. It fails the vertical line test. Because there's at least one x with more than one y. All right, example B. We're going to use the vertical line test again, and I'm just going to draw another straight up and down line, computer allowing. And I'm going to see if I sweep this line through this function, if there are any points where we cross the graph at more than one location. And I'm noticing, even though I didn't make my line quite long enough, no matter where I draw this vertical line, it will only cross the graph of the relation at one place. So this is a function. It passes the vertical line test. Abbreviate VLT. All right, last one, relation C. If I draw a straight vertical line and I go to kind of sweep this through this function, no matter where I am, I'm only hitting the graph at one spot. So notice if I extend this line more, even at this point right here, we would actually only be hitting the function at one place or at neither. So this kind of vertical line that goes down the middle where neither function is, I'm trying to get this to go away. No, let's just delete it. No, what just happened? That kind of invisible line that runs down here, that is what we call an asymptote, and the function will never actually cross that line. So there is no place where the graph will cross at more than one y value. So no matter where I am drawing that vertical line, it passes. So this is a function. It passes the vertical line test. Okay. Problem number 2. Is the set of ordered pairs a function? In our set of ordered pairs, we represent a set with these curly braces, and it is the points -6, 3, -9, 0, 0, 3, and -9, 4. So remember, if a relationship is a function, each input, each x value, has only one y. So I want to look for repeating x values here. So look for repeating x values. If I see x values that repeat with different y values, that means that there's an x value that has multiple corresponding y values. So I'm going to look at my x values. Our first x value is -6, and then we have -9. So these are both inputs. 0 is an input, and then I have, -9 again. So because I have two -9s, this is one x value or one input that has two different outputs. So this is not a function. All right, last example. Determine if the mapping represents a function. So here is our mapping. We have set A and set B. Set A is the numbers -2, 6, 10, and 18. And then set B is the numbers 1, 5, and 7, -7. It's not amazing, but it works. There we go. So, and then I need to draw my arrows. So -2 maps to 5, 6 maps to 5, 10 maps to 1, and 18 maps to 1. I don't like the last arrow, but it works. So we really want to see our inputs here are the values in set A. So this is like our inputs or our x values, and set B is our outputs. So I want to make sure that each input maps to only one output. If you have one arrow going to multiple places, that is an input with multiple outputs. So looking, -2 maps to 5, but it doesn't map anywhere else. So -2, 5, that's good. 6 maps to 5. It also does not map anywhere else. That's another point in our relation. 10 maps to 1, but it doesn't map anywhere else. And 18 also maps to 1, but it doesn't map to anywhere else. So even though I have multiple numbers in our input that are mapping to the same number in our output, and I also have a number in our output that isn't even being used, that's okay because each input maps to only one output. So this is a function. Alrighty. Please let me know what questions you have on this lesson, and remember that practice always makes perfect with this. Use those resources in the OMHS to help you.